Hey guys, we are starting our unit on quadrilaterals, and really it's going to be mostly about parallelograms and special types of parallelograms. So first we need to start off with the basics. So we're going to talk about polygons. Polygons are closed figures made up of sides so that each line segment, intersects exactly two other segments, but only at their end points. That means it doesn't cut through. Alright, over here on the left, we have examples of polygons. So on both of those, you can see that the sides are straight lines. We don't have any curves. Nothing cuts through. They're closed. They're exactly what we want in a polygon. Over here on the right, these guys are not polygons. So this first one, he is not a polygon because he's open. If you notice right here, there's a big gap. So he is not closed, and so that makes him not a polygon. Right here in this middle one, he has a curve. So since that side is not a straight line, that is not a polygon. Over here, this is what I mean by something cutting through. So that line that kind of goes through the middle of the shape, that makes it not a polygon. So when we talk about polygons, they have a bunch of different names. And we've talked about the first one already, a three-sided polygon. That, of course, is a triangle. This unit is about four-sided polygons. Those are called quadrilaterals. I know you might be thinking a square or a rectangle, but those are actually parallelograms, and those are actually special types of parallelograms. Quadrilaterals are any old shape with four sides. Alright, now we get into the gons. So 5 and above is all something gone. So 5 penta means 5. So pentagon is a 5-sided polygon. I bet you remember 6. 6 is a hexagon. Now 7 I always learned as a heptagon, but I have also heard septagon, so I will really take either one. Septagon sounds like it would be a transformer, like a Decepticon. Sorry. Anyways, 8 sides. That's an octagon, as I'm sure you probably just said to yourself. Nine sides is actually my absolute favorite to say. That's a nonagon. Alright, 10 sides. Deca, like decade. Deca means 10, so a decagon is 10 sides. Now, we skip over 11 because for some reason we just never run into 11-sided polygons. It's called a hendecagon, in case you really cared, but I had to look it up. It's not that important. 12 sides, that is called a dodecagon. Do means 2, deca means 10, so 12 is a dodecagon. Now, it would be a pain in the butt to look up how to name each polygon and things like that, because you really can have any number of sided polygon. So there's a way to set it up, but really we just put n-gon for anything that is not 3 through 10 and 12. Other than the ones we have listed here, we just go with whatever it is gone. So like, let's say that we have a 57 sided polygon, we would just call it a 57 gon, just so we don't have to go and figure out what it means, or what the word is. Okay, so let's talk about this unit's focus. We are looking at quadrilaterals. Quadrilateral is any polygon with 4 sides. So the big deal about quadrilaterals, 4 sides. The sum of the interior angles of a quadrilateral is 360 degrees. So one way to look at that, if we take that quadrilateral and draw a line through it, we end up with 2 triangles. And the sum of the interior angles of a triangle is 180 degrees. So we have 180 degrees here. We have 180 degrees here. All of that together makes 360. So angle A plus angle B plus angle C plus angle D equals 360. All right, here we go. So, oopsies, skipped over something. There we go. Forgot to actually do the math. So, MJKL is a quadrilateral. Find the missing angle. So, all those angles add up to 360. So, I will take 97 plus 75 plus 98 plus X equals 360. And then we'll combine like terms, 97 plus 75 plus 98. That's going to give us 270 plus X equals 360. We'll subtract 360 on both sides. X will equal 90. So that means that right here, angle L is 90 degrees. Or, if you would prefer, it's totally up to you. You can do exactly like we did with triangles. Take 360 and subtract out the other angles. 97 minus 75 minus 98. And pop that whole thing in your calculator and get 90 degrees. That is totally fine too. Whatever your style is works for me. So over here we've got X in 2 of our angles, but they want us to find the measure of angle W. So that means we're going to have to find X first and then plug it back in. So I'll take all of my angles, add them up, and set them equal to 360. So I have 99 plus 100 plus 23, oopsies, 23x minus 1 plus 17x plus 2 equals 360. So we'll combine all of our like terms. 99 plus 100 minus 1 plus 2, all of that together is 200. 23x plus 17x gives me plus 40x equals 360. So then the next thing I'll do is I'll subtract 200. So I end up with 40x equals 160. I'll divide by 40. So I'll get that x equals 4. But remember, that's not what they were asking for. They wanted the measure of angle W. So we're going to need to plug it in. 17 times 4 plus 2. And if you throw that into your calculator, you're going to see that the measure of angle W is equal to 70 degrees. Alright, so the next stuff that we're talking about is going to be really stinking important. This next, 5 pieces of information are very important. This is something you might want to highlight in your notes, or put a little star next to, or something like that, so that way you can come back to this, because these 5 pieces of information are going to be really, really important. So, first of all, a parallelogram. That parallel part is important. So, a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. So that means that AD is parallel to CB, and DC is parallel to AB. So an important thing to remember here is that those little arrows, that means parallel. It does not mean that they're congruent. Congruent is tick marks. It's different. So we want to remember AD, or one side, is parallel to, remember those two little lines mean parallel to BC, and DC is parallel to AB. I have 2 pairs, both pairs of opposite sides parallel. That's important. Alright, so that's the definition of what a parallelogram is. Now we have some properties of parallelograms. I'm sorry, I lost my train of thought. Alright, so if a figure is a parallelogram, that means that both pairs of opposite sides are going to be congruent. So that means those sides that were parallel, they're also going to be congruent to each other. So AD is going to be congruent to BC, and AB is going to be congruent to DC. Opposite angles are going to be congruent. So opposite angles would be like angle D and angle B. Opposite means they're across from each other. So angle D would be congruent to angle B. And it even kind of looks like that. They're both obtuse, so that's a good sign. And that also means that angle A is going to be congruent to angle C, since they are opposite. So angle D is going to be congruent to angle B, and angle A is congruent to angle C. Alright, now if you remember when we had consecutive interior angles or same side interior angles, they were supplementary. That's pretty much the same thing we have here. So if we have angles that are consecutive or in a row, they are going to be supplementary. Remember, supplementary means they add to equal 180 degrees. So that means that angle D and angle A, when you add them up, they are going to equal 180 degrees. Angle A and angle B, when I add them up, they are going to equal 180 degrees. Angle C and angle B, when I add them up, I want them to equal 180 degrees. Angle D and angle C, when I add them up, I want them to equal 180 degrees. I want them to be supplementary. All right. Then the last one, diagonals of a parallelogram bisect each other. So diagonals bisect. That's important. So what that means is that this whole diagonal DB is going to be bisected. So that means DE is going to be congruent to EB. That means E is going to be the midpoint of both of these guys. So AE is going to be congruent to EC. So it's going to, each of those diagonals is going to be cut in half. All right, so here we go. Let's start looking at some math. Over here, we are looking at opposite sides on this first one. So we'll see that opposite sides are both parallel, but they are also congruent. So since those opposite sides are congruent, congruent means that they are equal. So x equals 10. Over here on this next one, we're looking at opposite angles. Opposite angles are congruent. So I set congruent things equal to each other. So x equals 106. Over here on this guy, these angles are in a row. And when angles are, oopsies, not in an array, in a row. There we go. So, if they are in a row, they are going to add up to 180 degrees. So, if I take if I have 75 plus x equals 180, we're going to get that x equals 105. Or you can take 180 minus 75, and you would get the same answer. All right, on this next guy, we have diagonals. And we know that the diagonals are going to bisect each other. So if first we look at x, we're looking at the diagonal of QS. So that means that the other part that it's going to be congruent to is going to be down here, 12. So x will equal 12. Y is over here on the diagonal of PR. So I'm going to set it equal to the other side of 8. So y equals 8. All right, so if we go ahead and look at W first, its opposite angle in the quadrilateral is going to be that 113. So that means W is going to be 113 because opposite angles are congruent. Now, we're going to go back to something we talked about a long time ago. So right here, we know that since it's a parallelogram, opposite sides are parallel, right? So when I have these two parallel lines, and then that line through the middle of the parallelogram is our transversal. So I have alternate interior angles. So I know x is going to be equal to 39. And what I also can see is that y is going to be congruent to z. But I first need to figure out what that's going to be. So if I know that x is 39 degrees, I now have this triangle right in here. that I'm outlining in red right now. So all those angles are going to add up to 180 since it's a triangle. So I have 113 plus 39 plus y equals 180. And when I take 180 and I subtract out those other angles, y is going to equal 28. And since y equals z, that means z equals 28. So having those parallel lines is really helpful. It gives us a lot of different angles in there. There's just oodles of congruent stuff when we do that. All right, let's keep going. All right, on this next one, I have opposite sides, and we know that opposite sides are congruent. And what do we do with congruent things? We set them equal to each other. So I have 9x plus 2 equals 20. So next I'll subtract 2. 9x will equal 18. Then I'll divide by 9 on both sides, and x will equal 2. Over here on the next one, we have opposite angles. Opposite angles are congruent. So I'm going to go ahead and set those two guys equal to each other. Since opposite angles are congruent, 8x plus 4 equals 68. And then to start solving, I'm going to go ahead and subtract 4. So 8x equals 64. Then I'll divide by 8 on both sides, and x will equal 8. Oh, weird looking 8. Let's try that again. That's better. All right, here in this next one, we have consecutive angles, or angles in a row, and they are going to add up to equal 180 degrees. They are supplementary. So I'm going to add them up. 36x plus 2 plus 70 equals 180. So I will go ahead and combine like terms. So I'll have 36x plus 72 equals 180. Then we'll subtract 72 and get that 36x equals 108. Then we'll divide by 36, and x will equal 3. All right, over here on this next one. So let's start with, since we're talking about diagonals, let's remember that diagonals bisect each other. So over here, 50 is on that diagonal of MP. So these two little bits, 3x plus 2 and 50, those two parts are going to be congruent. So since they're congruent, I'll set them equal to each other. 3x plus 2 equals 50. Then I'll subtract 2. 3x equals 48. Then I'll divide by 3. X will equal 16. All right, so now on this other guy, I have 5x. He's on the diagonal of NQ. So I'm going to set that equal to the other part of NQ. So 2y plus 50 is going to be equal to 5x. So 5x equals 2y plus 50. Now, we were lucky enough to figure out x first, so we're just going to go ahead and plug him in. So I'm going to have 5 times 16 equals 2y plus 50. So 5 times 16 is 80. Oh, is that right, Peanut? Equals 2y plus 50. Then I'll subtract 50 and get 30 equals 2y. Divide by 2, y will equal 15. So, go ahead and get started on your homework.